Top 1. The Antikythera Mechanism. In the year 1900, a Greek sponge diver named Elias Stadiatis descended into the Aegean Sea and surfaced screaming about corpses on the seafloor. They were actually bronze statues. The wreck they originated from was a Roman cargo ship that had sunk sometime around 60 BCE, loaded with marble sculptures, pottery, coins, and wine jars. Archaeologists recovered everything. Among the finds was a lump of corroded bronze the size of a shoebox, which was placed in a storage room at the Athens National Museum and largely forgotten for 2 years. When someone finally examined it closely, what they discovered inside that corrosion changed everything we thought we knew about ancient technology. It was a machine, a computing device built from at least 37 interlocking bronze gears. The next device of comparable mechanical complexity would not appear in the historical record for another 14 centuries. Physicist and science historian Derek de Solla Price published the first serious analysis of the mechanism in 1974 in a paper titled Gears from the Greeks, establishing beyond reasonable doubt that this was an astronomical computer of extraordinary sophistication. However, it was the high-resolution CT scanning conducted by the Antikythera Mechanism Research Project, led by Tony Freeth and Mike Edmonds of Cardiff University, beginning in 2005, that revealed the full depth of what the Greeks had constructed. The mechanism predicted solar and lunar eclipses and tracked the cycles of at least 5 known planets. It calculated the 19-year Metonic cycle, in which 235 lunar months align almost perfectly with 19 solar years. It tracked the 76-year Callippic cycle and computed the 223-month Saros cycle for eclipse prediction, all simultaneously. These were all displayed on interlocking dials on its front and back faces. The gear-train ratio required to encode the Saros cycle alone is 223 to 1. Modern clockmakers describe achieving this in bronze with hand tools as remarkable engineering for any era, not just for the ancient world, but for any era. The wreck has been dated by recovered coins to approximately 60 to 70 BCE. Metallurgical analysis of the mechanism itself suggests it was manufactured between 150 and 100 BCE. An inscription on its casing references 76 years, the Callippic cycle, and mentions the island of Rhodes, leading historian Alexander Jones of New York University to argue it was likely built in a Rhodian workshop, possibly connected to the astronomical tradition of Hipparchus. In 2022, a new fragment of the mechanism was recovered from the seafloor during the ongoing Antikythera shipwreck project led by Brendan Foley of Lund University, suggesting the original device was larger than any current reconstruction accounts for. We have been studying this object for over a century, and it is still growing. The mainstream explanation is straightforward and, in its own way, deeply satisfying. The Hellenistic world produced Archimedes, hero of Alexandria, and Ctesibius of Alexandria, engineers and mathematicians of staggering capability. The Antikythera mechanism is the pinnacle of that tradition, a one-of-a-kind instrument likely commissioned by a wealthy patron for education or display. Its disappearance from history is simple. It was lost at sea. The workshop that made it eventually closed, and the tradition died with the craftsmen who carried it. Brilliant minds, but no institutional continuity. The knowledge evaporated, but that explanation carries a weight it can barely support. The Romans absorbed Greek engineering wholesale. They built aqueducts, concrete, road networks, heated floors, and harbors that required mastery of hydraulics and material science. They had every motive to preserve and reproduce a device this useful for navigation, timekeeping, and calendar prediction. And yet, in 1,000 years of Roman civilization, nothing approaching 37 interlocking gears computing planetary motion appears in any text, any excavation, or any description. Not a fragment, not a reference, not a rumor. The mechanism doesn't just represent lost knowledge, it represents a lost knowledge tradition so completely severed that the civilization that followed it, the civilization that inherited everything else, apparently never even knew it had existed. What else did the ancient world build and lose? What other machines are sitting on other seafloors waiting for someone to pump out the water? Top 2. Puma Punku. From the bottom of the Aegean, we cross oceans and climb to nearly 13,000 feet above sea level to a plateau in the Bolivian Andes, where someone cut stone harder than steel to tolerances that would challenge a modern machine shop. This is Pumapunku. Stand on the Bolivian Altiplano at 12,800 feet, and the air will make your lungs ache before you take 10 steps. The nearest city is 45 miles away. The nearest quarry for the stone beneath your feet is 60 miles away on the other side of a lake. The stone itself, dark gray andesite, ranks 7 on the Mohs hardness scale. Harder than steel and harder than the bronze or copper tools available to anyone who lived here. And yet, scattered across this windswept plateau are H-shaped stone blocks, cut to tolerances of less than a millimeter, with internal channels that maintain consistent width along their entire length, and holes drilled through them that show no evidence of the gradual widening you would expect from stone-on-stone abrasion. They look machined. Engineers who examine them say that word without prompting, then pause because they know what it implies. Pumapunku is part of the Tiwanaku complex near the southern shore of Lake Titicaca. The site has been known to Western scholars since the Spanish conquistador Pedro Cieza de León described its ruins in 1549. Systematic archaeological work began in the 1870s with Ephraim George Squire. Arthur Posnansky, the Austrian-Bolivian archaeologist who spent the first half of the 20th century studying Tiwanaku, made a claim in his 1945 work, Tiwanaku, the Cradle of American Man, that the mainstream has spent 80 years arguing against, that stellar alignments at the site indicate an original construction date of approximately 15,000 BCE. This claim remains unresolved. The official mainstream dating places peak Tiwanaku activity between 400 and 900 CE. What is not disputed is what the stones themselves look like up close. Jean-Pierre Pratzen of the University of California, Berkeley, who devoted decades to studying Indian stone-cutting techniques at Sacsayhuaman and other Inca sites, concluded that the techniques used at Pumapunku were distinct from and more precise than anything documented elsewhere in the Indian world. The H-blocks are uniform across hundreds of individual pieces, each with identical internal dimensions and interlocking features, as if produced from a master template that could not tolerate deviation. The andesite blocks were quarried from the Copacabana Peninsula on the opposite shore of Lake Titicaca, 90 kilometers away across open water. The largest single stone on the site weighs approximately 131 metric tons, the weight of a fully loaded Boeing 747. It was moved 90 kilometers uphill to an altitude of nearly 4,000 meters by a culture with no iron tools, no wheel, and no written record of how they did it. The mainstream view holds that the Tiwanaku civilization was a sophisticated state society with the organizational capacity to manage large-scale quarrying and transport operations. Reed rafts on Lake Titicaca could theoretically carry the stone. Sufficiently large labor forces coordinated over generations can achieve extraordinary results. The precision of the H-blocks reflects a template system and skilled craftspeople working with stone-on-stone abrasion over long periods, slow but effective. This is a serious argument backed by the same logic that explains the pyramids, Stonehenge, and every other monument that once seemed impossible. But no experimental archaeology team has successfully transported a multi-ton andesite block across open water conditions on a reed raft and up to altitude. The attempts have been made, but the results have been inconclusive at best, and the precision argument runs into a physical wall. Stone-on-stone abrasion produces characteristic marks, slight widening, irregular depth, and tool drift. The internal channels of the Pumapunku H-blocks show none of these. What they show is consistency that stonecutters and machinists describe as inconsistent with hand tool production in hard stone. Some researchers have proposed that the construction date is simply wrong, that the blocks were cut by a civilization that predates Tiwanaku by thousands of years, a civilization with tool technology we have not yet identified and possibly can identify because it left no other trace. Posnansky's stellar alignment argument, if even partially correct, puts original construction at a time when the tools and civilization required to produce these cuts would need to have existed thousands of years before any culture we currently recognize in the Americas. We don't know what those tools were. We don't know who used them. What we know is that the cuts are there in stone harder than steel at 13,000 feet, and they are not explained. Pumapunku's builders left no writing, no portraits, and no named kings. What they left is the stonework itself. Top 3. Nan Madol. Our next civilization left a different kind of impossibility. A city built on nothing but water and coral in the middle of the world's largest ocean, by people whose oral tradition says the stones simply flew. This is Nan Madol. There is no logical reason for Nan Madol to exist. It sits on an open ocean tidal flat off the eastern shore of Pohnpei Island in Micronesia, with no fresh water, no farmland, and no stone quarry within reasonable distance. The nearest landmass of any consequence is 2,500 miles away. And yet someone built a city here, not a village, but a city of 92 artificial islands. Each was constructed by stacking prismatic basalt logs in an interlocking pattern without mortar, rising to walls 7 meters high and covering a total area of roughly 18 square kilometers. The total volume of basalt involved in the construction is estimated at 750,000 metric tons. Individual columns weigh up to 50 tons. When researchers ask the people of Pohnpei how their ancestors moved stones of that weight across the open ocean in canoes, the answer has been consistent for as long as anyone has been recording it. The stones flew. The site was largely unknown to Western scholarship until Russian explorer Fyodor Littke referenced it in 1828. Systematic carbon dating of organic material trapped beneath the foundations was conducted by archaeologist Rufino Mauricio, placing the earliest construction phases at approximately 200 BCE, with the main ceremonial core, a structure called Nandawas, built between 1200 and 1500 CE. Geologist William Ayres of the University of Oregon confirmed in field studies that the columnar basalt originated from at least 2 quarry sites on Pohnpei, one on the north coast and one on the opposite western side of the island. Both were accessible only by sea. The basalt columns are naturally prismatic and hexagonal in cross-section, a product of how basalt cools, but they had to be identified, harvested, loaded onto some form of watercraft, transported around the island in open Pacific conditions, and then stacked to heights of 7 to 8 meters with enough precision to create walls that have survived for centuries. The largest structure, Nandawas, functions as a royal tomb, with thick external walls enclosing a central burial chamber where human remains were found. The architecture follows a logic of permanent occupation. The walls are built to last, and the interior spaces are deliberate and functional. The engineering of the stacked columns distributes weight in a way that resists collapse. Magnetometer surveys of the basalt have confirmed that many of the columns carry a slight magnetic charge. They are weakly magnetized. This detail appears in almost every serious engineering study of the site and is then quietly set aside because no one has a satisfying explanation for what it means or whether it is relevant to how the stones were placed. The mainstream archaeological view is that the Saudeleur dynasty, which ruled from Nan Madol, commanded sufficient political authority to conscript labor from across Pohnpei and surrounding islands. Micronesian seafaring tradition is among the most sophisticated in the world. These were ocean navigators who crossed the Pacific in open canoes using stars, swells, and wind patterns. Large bamboo rafts could theoretically transport the columns. Construction over 500 to 800 years makes the cumulative scale manageable. This explanation respects the genuine genius of Micronesian maritime culture and is the working consensus of the archaeologists who have studied the site most carefully. But no experimental archaeology team has transported a 50-ton basalt column by any method across open Pacific Ocean conditions. Not a partial demonstration, not a scaled model. The Polynesian and Micronesian voyaging traditions are documented and extraordinary, but they involve lightweight canoes carrying human bodies, not 50-ton stone cargo. The physics of floating a column that heavy on a reed or bamboo raft in Pacific swells, and then lifting it to a height of 7 meters to be placed precisely in an ongoing construction project, has never been demonstrated in practice. The oral tradition of Pohnpei describes the founders of Nan Madol as 2 brothers who arrived from a foreign land and possessed the ability to make stones rise through the air. This is dismissed by historians as mythology, but it is specific mythology consistent across generations, describing a specific engineering capability. The Sodalur are also described as having come from elsewhere, a foreign origin that no genetic or linguistic study has yet traced conclusively. Somewhere, someone built Nan Madol in the middle of the ocean with 50-ton stones, and then they either forgot how or they never told anyone who wrote it down. Top 4. The Indus Valley Civilization. From a city on the open ocean, we traveled to the plains of the Indus River, where a civilization that left no kings, no temples, and no war monuments somehow built the world's most advanced urban infrastructure 4,000 years before anyone thought to match it. This is the Indus Valley Civilization. The year is 2600 BCE. In Mesopotamia, kings are burying servants alive in their tombs. In Egypt, tens of thousands of workers are hauling limestone slabs across the desert to glorify a single man. And on the banks of the Indus River, in what is now Pakistan, an unknown civilization is doing something that neither of those cultures managed, and that Europe would not achieve for another 4,000 years. They are building cities with sewers, not open trenches. Covered brick sewers ran beneath every major street, connected to individual bathrooms in nearly every house, carrying waste away from the population to collection points outside the city limits. The city of Mohenjo-Daro at its peak housed an estimated 40,000 people. Every one of them had access to sanitation infrastructure that London didn't match until 1865 CE. British archaeologist John Marshall directed the first systematic excavations at Harappa in Mohenjo-Daro for the Archaeological Survey of India in 1920 and 1921. What he found stunned the academic world. Two large, clearly planned cities connected to each other and to hundreds of smaller settlements across a territory larger than ancient Egypt and Mesopotamia combined, yet not mentioned in any known ancient text. Streets ran in cardinal grids. The Great Bath at Mohenjo-Daro, 12 meters long, 7 meters wide, and 2.5 meters deep, was lined with tightly fitted brick and sealed with a layer of bitumen waterproofing, a technique not used in any other known Bronze Age construction. Inspection manholes gave access to the drainage channels at regular intervals. There were standardized weights and measures consistent across the entire civilization's geographic range. The brick ratio is one of the most quietly astonishing facts about this culture. Every baked brick found at every Indus Valley site, from Mohenjo-Daro in Sindh to Lothal in Gujarat, across more than 1 million square kilometers, maintains the same dimensional ratio of 1 to 2 to 4. Every brick across an area the size of Western Europe for centuries. That doesn't happen by accident. It requires either a centralized manufacturing standard or a cultural commitment to uniformity so deep it functioned as a kind of law. Jonathan Mark Knoyer of the University of Wisconsin-Madison, who has directed excavations at Harappa since 1986, has noted that skeletal analysis of the population shows remarkably uniform bone density and nutritional health across individuals from different areas of the city, suggesting an equality of diet and physical condition that is effectively unparalleled among Bronze Age urban populations anywhere. There are no palaces, no temples, no royal tombs, and no monuments to any individual human being anywhere in the entire civilization. There is no evidence of a military, no mass graves of conquered peoples, and no iconography of rulership or divine kingship. The political and religious vocabulary that defines every other complex society of the era, from the pharaohs of Egypt to the priest-kings of Sumer, is absent. In its place are granaries, public baths, assembly halls, and streets so logically organized they look planned from above. Researcher Rajesh Rao of the University of Washington published an analysis in Science in 2009, arguing that the statistical structure of the Indus script matches known language patterns, confirming it is almost certainly a true writing system. We have 4,000 artifacts bearing this script, yet we cannot read a single one. The mainstream explanation is that the Indus Valley Civilization represents a Bronze Age urban society that solved the practical problems of dense human settlement through incremental development over centuries. The sanitation system reflects rational problem-solving in a warm climate where disease pressure made waste management urgent. The absence of monumental architecture may reflect a genuinely different political structure, perhaps a merchant oligarchy or council governance, rather than divine kingship. The brick standardization evolved from shared technical traditions. All of this is reasonable and probably partly true. But the Indus script has resisted every computational and linguistic tool brought to bear on it for over 100 years. This is the writing system of a civilization that housed 40,000 people in a single city, maintained identical brick standards across 1 million square kilometers, and built drainage infrastructure 4 millennia ahead of its time. And we cannot read what they wrote. They left us their cities, their bricks, and 4,000 inscribed seals, and then they vanished. Their cities were abandoned around 1800 BCE without a clear destruction layer. Their population dispersed, and their language was sealed behind a script that has defeated everyone who has tried to open it. Whatever the Indus Valley knew about organizing human life, we have not yet earned the right to understand it. Top 5. The Nazca Lines from the Plains of the Indus. We traveled to the South American desert to a plateau where someone drew the largest art gallery on Earth for an audience they never expected to stand among. These are the Nazca Lines. From ground level, you see nothing, just a shallow scraping in the desert floor, a line of reddish-brown gravel displaced to reveal lighter earth beneath. You could walk across a hummingbird 93 meters long and never realize you were inside it. The full image, the curve of the wing, the elongated beak, the precision of the proportions, only becomes coherent at an altitude of roughly 300 meters. This raises a question that has occupied researchers for nearly a century. Why did a civilization that lived and died at ground level spend generations creating images that only make sense from the sky? The Nazca Lines were first noticed by Western observers in the 1930s when commercial airline pilots flying over the Ica region of southern Peru began reporting enormous figures etched into the desert floor. Peruvian archaeologist Toribio Mejia Gespe had spotted them from a hilltop in 1927. German mathematician Maria Riesch arrived in 1946 and spent the next half-century mapping, measuring, and protecting the site, refusing payment and sleeping in a sleeping bag on the desert floor. Thermoluminescence dating of ceramic fragments at the geoglyph sites and radiocarbon dating of wooden stakes found at line endpoints place construction between approximately 200 BCE and 600 CE, identifying the creators as the Nazca culture of coastal southern Peru. What they left behind is staggering in scale. Over 800 straight lines, 300 geometric shapes, and more than 70 animal and plant figures, including a condor with a wingspan of 130 meters, a spider 46 meters across, and a humanoid figure 30 meters tall carved into a cliff face, sometimes called the astronaut for reasons that become obvious when viewed from altitude. The straight lines are the most technically baffling element. Some run for 48 kilometers across the plateau, crossing valleys, ridges, and uneven terrain, while maintaining directional accuracy to within approximately 1 degree of deviation over their entire length. This consistency over real topography, rather than flat ground, has never been successfully replicated in experimental archaeology using only the tools and materials available to the Nazca. Astronomer Anthony Avini of Colgate University, who has conducted the most comprehensive surveys of the line's astronomical orientations, found that a statistically significant number point towards sunrise, sunset, and key stellar events during the construction period, particularly the Pleiades and the star Shinar. In 2020, Japanese researcher Masato Sakai of Yamagata University announced the AI-assisted identification of 143 previously unknown geoglyphs, including a 30-meter decapitated humanoid figure invisible to the naked eye from any ground-level position. We are still finding images. The mainstream explanation, developed largely through Aveni's work, holds that the lines serve multiple overlapping purposes. Ritual pathways walked by participants in water and fertility ceremonies. Astronomical markers tied to seasonal cycles and the Nazca calendar, and territorial identifiers for different clans or lineages. Researcher David Johnson proposed that many of the straight lines map underground aquifer systems, the desert's invisible water network, giving the geoglyphs a practical ground-level purpose that has nothing to do with aerial viewing. This is a serious hypothesis supported by hydrogeological data. The figures themselves in this reading were meaningful to walk through and around, experienced as landscapes rather than images. But the figures are portraits: the hummingbird, the condor, the spider. These are biological renderings of specific species executed with proportional accuracy that only becomes visible from altitude. A ritual participant, walking the path of the hummingbird's wing at ground level, experiences only a line in the dirt. The meaning, the image, the identity, and the art exist only from above, and the 48-kilometer straight lines crossing broken terrain with 1-degree accuracy have not been replicated in experimental conditions on the actual plateau geography. Despite genuine and sustained attempts, some researchers have proposed, not entirely fancifully, that the Nazca possessed elevated viewing capability, high-altitude tethered balloons made from local cotton and reed materials entirely within their technological range. Researcher Jim Woodman demonstrated in 1975 that a balloon constructed from Nazca period materials could achieve flight. This doesn't prove the Nazca used them. It only proves the concept was within reach. The more unsettling possibility is simpler, that these images were made for a viewer the Nazca knew would never stand among them, a viewer from above. Whatever they were reaching toward, they spent generations on it, and they made it permanent. Top 6. The Maya Venus Tables. From a desert floor that hides its meaning from those standing on it, we traveled to the jungle cities of Mesoamerica, where a civilization without telescopes tracked the movement of a planet to an accuracy that 14 centuries of European astronomy barely improved upon. These are the Maya Venus Tables. Deep in a rainforest so thick it hid entire cities for 1,000 years after they were abandoned, a civilization invented the concept of zero, not borrowed it, not inherited it, but invented it independently from scratch in a jungle using a base 20 number system they built themselves. Then they used that mathematics to track the planet Venus across a 1,000-year observational record, accumulating an error of less than 2 hours per year without a telescope, without a mechanical clock, without a heliocentric model of the solar system, and without any of the tools that European astronomers required to approach the same accuracy in the 17th century CE. Whatever the Maya knew about the sky, they knew it in a way that our timeline of intellectual progress has no clean explanation for. The Dresden Codex is one of only 4 pre-Columbian Maya books to survive the Spanish conquest and the mass burning of Maya texts ordered by Bishop Diego de Landa in 1562. It was acquired by the Royal Library of Dresden around 1739. Ernst Furstemann, the library's chief librarian, decoded its Venus tables between 1880 and 1906, establishing that pages 46 through 50 encode a 104-year mathematical cycle tracking Venus's synodic period, the time between successive appearances as the morning star. With accumulated precision that Furstemann described as remarkable by any standard of astronomical record-keeping, the Maya figure for the Venus cycle was 583.92 days. The modern measurement is 583.92 days. The correction cycles applied every 8 years, and again every 57 years reduce accumulated error to roughly 0.08 days per Venus cycle, 2 hours per year across 1,000 years of observation. Astronomer Anthony Aveni of Colgate University documented in peer-reviewed work that the E-group architectural complexes found at dozens of Maya sites, a specific arrangement of a pyramid facing a long eastern platform, function as horizon calendars. The corners and center of the eastern platform mark the positions of sunrise at the solstices and equinoxes, accurate to within a day. The observatory tower at Caracol in Belize contains windows aligned with Venus's extreme rising and setting positions. The Maya weren't building temples and accidentally noticing the stars. They were building instruments and calling them temples. The Dresden Codex also contains a lunar eclipse table, tracking a 405-month cycle with predicted eclipse dates that researcher Floyd Lounsbury of Yale University demonstrated match actual eclipse records to within 1 to 2 days over a 33-year span. The long count calendar, which encodes all of this mathematics, uses a positional vigesimal notation system that requires 0 as a placeholder. The earliest confirmed Maya 0 appears on a stela dated to 357 CE, though some researchers place the conceptual development earlier in the pre-classic period, potentially before 0 appeared in the Indian mathematical tradition. The mainstream explanation is straightforward. In a theocratic political system, where the ruler's legitimacy depended on control of time and the ability to predict celestial events, the incentive to develop precise astronomical tools was enormous. Centuries of careful, naked-eye observation, cross-generational record-keeping, and mathematical refinement produced the Venus tables. The independent invention of zero reflects a universal logical necessity. Positional notation demands a placeholder, and any culture that develops positional notation will eventually invent one. Motivation, time, and accumulated observation explain everything here without requiring any external source of knowledge. But motivation explains why they tried. It doesn't explain how they succeeded to 2-hour per year accuracy across a millennium of observation without any of the instruments that European astronomy required to achieve comparable results. The Maya didn't have a heliocentric model. They didn't know Venus was a planet orbiting the sun. They were tracking an apparition in the sky, a bright object that appeared and disappeared on a cycle, and they modeled that cycle with greater precision than any civilization would achieve again for over 1,000 years. Some researchers have asked whether the Maya inherited the core of their astronomical tradition from the Olmec civilization that preceded them rather than building it from scratch. The Olmec occupied the same region from 1500 to 400 BCE and show evidence of astronomical awareness whose full extent is only beginning to be understood. If the Maya were standing on older shoulders, the question becomes, how high did those shoulders reach? Top 7. The Great Pyramids encoded mathematics. From intellectual precision encoded in bark paper, we move to a plateau in Egypt, where someone appears to have encoded the deepest constants of the physical universe into the dimensions of a single stone building 2,000 years before those constants were formally measured. These are the Great Pyramids encoded mathematics. It is the only surviving wonder of the ancient world. We have had 4,500 years to study it, yet we still cannot agree on how it was built. But the deeper argument isn't about logistics, it's about the numbers. Because whoever designed this structure appears to have known the value of pi, the golden ratio, the circumference of the Earth, the mean distance from the Earth to the Sun, and the speed of light in meters, and encoded each of them into the proportions of a single stone building 25 centuries before the Greeks formalized geometry and 45 centuries before any of these constants were formally measured. Either that is the most extraordinary sequence of coincidences in architectural history, or someone in 2560 BCE knew things they had no business knowing. A GPS survey conducted by Glenn Dash of the Glenn Dash Research Foundation and Mark Lenner of Ancient Egypt Research Associates, published in the Journal of Ancient Egyptian Architecture in 2015, confirmed that the Great Pyramid's alignment to true north deviates by just 0.067 degrees, approximately 4 arc minutes. This is the most precisely north-aligned large structure ever measured from antiquity. In 2560 BCE, without a magnetic compass, without GPS, and without the ability to observe Polaris, which was not the pole star at that time, achieving 4 arc minutes across a 230-meter base required either an astronomical technique of extraordinary precision or instrumental capability we have not identified. The base of the pyramid is leveled to within 2.1 centimeters across its entire length. A leveling achievement that structural engineers note is essentially at the limit of what standing water leveling channels can achieve on non-uniform bedrock. Then there is the mathematics. The base perimeter of the Great Pyramid divided by twice its original height gives the value of pi to 4 decimal places. Egyptologist Kate Spence and others have argued this arises naturally from the Egyptian Seked construction system, a practical slope ratio of 14 to 11 that produces proportions approximating pi without requiring abstract mathematical knowledge of the constant. This is a serious counter-argument, but it is an argument for approximation, not for decimal place precision. The golden ratio appears in the relationship between the pyramid's slant height and half its base. The pyramid's height of 146.5 meters multiplied by 1 billion gives approximately 146.5 million kilometers, within 1% of the actual mean Earth-Sun distance. The geographic coordinates of the Great Pyramid are 29.9792458 degree and N. The speed of light in meters per second is 200.792 on 458. The coordinate matches the speed of light value to 8 significant figures. Robert Bauval's Orion correlation theory, proposed in 1994, argues that the layout of the three Giza pyramids mirrors the three belt stars of the constellation Orion as they appeared in approximately 10,500 BCE, suggesting the site plan was calculated by reference to a stellar configuration 6,000 years before construction began. The mainstream explanation, represented most comprehensively by Egyptologist Mark Lehner, is that the pyramid's mathematical properties arise from practical construction geometry rather than abstract theoretical knowledge. The Sikht system naturally produces proportions near pi and phi. The alignment reflects known Egyptian star sighting techniques. The speed of light coordinate is post hoc pattern recognition by modern observers projecting a unit of measurement, the meter, that didn't exist until the 18th century CE. These are serious arguments. The CCAD explanation for the pi relationship is genuinely compelling, but the CCAD system produces proportions near pi, not pi to 4 decimal places. The alignment to 4 arc minutes across 230 meters has no parallel in any other ancient structure anywhere on Earth. The leveling to 2 centimeters across non-uniform bedrock at Giza pushes the limits of the technique proposed to explain it. And the speed of light coordinate either requires the meter as a deliberate unit of measurement, which implies knowledge of the Earth's circumference to the precision required to define the meter, which the pyramid's geometry also appears to encode, or it is a coincidence of 8 significant figures. Some researchers, following the tradition of John Anthony West and René Schwaller de Lubitsch, have argued that Egyptian mathematical knowledge was not primitive and practical, but sophisticated and deliberately preserved, that the pyramid is a library in stone designed to transmit specific values across any span of time to anyone with the tools to measure it. If they are right, someone in 2560 BCE was leaving us a message. We have the tools to read it now. We just haven't agreed on what it says. Top 8. Çatalhöyük. From the mathematical precision of Egypt's most famous monument, we travel back in time 6,000 years to a city in Anatolia that housed 8,000 people, had no streets, no kings, and no war, and ran for 1,800 years without collapsing. This is Çatalhöyük. The year is 7,000 BCE. The wheel is 3,500 years from being invented. Writing is 4,000 years away. Stonehenge is 4,500 years in the future. And on a flat plain in what will one day be south-central Turkey, up to 8,000 people are living together in a dense honeycomb of mud brick rooms, managing long-distance trade networks, repainting their walls in elaborate murals up to 120 times over multiple generations, burying their dead beneath their floors, and organizing collective life at a scale and sophistication that no civilization would equal in the same region for another 3,000 years. They had no streets. They had no doors at ground level. Every room was accessed through a hole in the roof, and every house was the same size. British archaeologist James Mellart discovered the site in 1958 and excavated it until 1965, producing results so startling they were initially met with skepticism, verging on institutional resistance. Excavations resumed in 1993 under Ian Hodder of Stanford University, whose project has become one of the most meticulously documented ongoing excavations in archaeological history. Radiocarbon dating confirmed continuous occupation from approximately 7,500 to 5,700 BCE, a span of 1,800 years. Obsidian sourced from volcanic fields in Cappadocia, 200 kilometers to the north, constitutes a significant proportion of the cutting tools found throughout the settlement. Neutron activation analysis confirmed the sourcing. This is a sustained long-distance trade network operating in the Neolithic period, centuries before the first recognized urban trade systems anywhere in the ancient Near East. Bioarchaeologist Clark Spencer Larson of Ohio State University, working as part of Hodder's research project, conducted osteological analysis of skeletal remains from different areas of the settlement and found no significant difference in femoral cross-sections, dental health, or nutritional markers between individuals. In every other Bronze Age civilization we study, Egypt, Mesopotamia, the Indus Valley, the bones tell a story of inequality. Palace diets and peasant diets produce different skeletons. At Çatalhöyük, the bones are the same. 8,000 people, the same food, the same physical workload, the same health outcomes. That is not a natural equilibrium. That is a sustained social achievement. The walls were replastered repeatedly in some rooms more than 60 times, each fresh coat of white plaster bearing new paintings of hunting scenes, geometric patterns, and human and animal figures. The dead were buried beneath the floors of the rooms where their descendants slept. Ian Hodder has argued this represents a form of ancestor veneration that structured social memory and property rights without formal institutional religion. The dead as literal foundation, kinship as the organizing principle of space itself. There is no palace district, no temple complex, and no monument to any individual human being. The closest architectural analog to a large public space is a granary. Whatever held 8,000 people together in a city for 1,800 years, it was not a king and it was not a god. It was something else, something we don't have a clean word for. The mainstream explanation, articulated by Hodder himself, is that Çatalhöyük was an agglomerated settlement model, people living in dense proximity for mutual social and physical security, organized by kinship networks rather than political hierarchy. The complexity is real but accumulates gradually over 1,800 years of continuous occupation. The egalitarianism is genuine but not unique. Small-scale Neolithic societies frequently show low social differentiation before the emergence of surplus agriculture and formal institutions. But 1,800 years is not gradual, it is sustained. Managing population growth, resource allocation, dispute resolution, and trade networks across nearly 2 millennia in a fixed physical space without streets, without formal governance structures we can identify, and without collapse. That is not the absence of social technology. That is the presence of one we don't recognize. Çatalhöyük was abandoned around 5,700 BCE peacefully, without a destruction layer. No fire, no massacre, no epidemic. The population dispersed to smaller settlements across the surrounding plain, leaving everything intact, as if they had simply decided the experiment was complete. Top 9, the Longyu Caves from a city that remembered its dead beneath its floors. We descend underground to 36 colossal caverns in China that no one recorded, no one remembered, and no one has ever explained. These are the Longyu Caves. In June of 1992, a farmer named Wu An'ai decided he was tired of pumping water out of a flooded pond on his land near Longyu County in Zhejiang Province, China. He rented a pump and ran it for 17 days. When the water was finally gone, he climbed down into what he thought was a natural cavity. He found a man-made room the size of an aircraft hangar, walls carved smooth from floor to ceiling, supporting pillars left in place with mathematical precision. Every surface covered in parallel chisel marks arranged at exactly 60 degrees to the horizontal, consistent, undeviating, identical. He had found one room. There were 35 more. 36 colossal underground caverns covering a total floor area of 30,000 square meters, the equivalent of 5 Colosseum floor plans stacked side by side. No rubble, no tools, no bones, and not a single line in any Chinese historical record suggesting they had ever existed. The initial archaeological assessment by the Zhejiang Province Cultural Relics Bureau confirmed the caves as definitively artificial. No natural geological process produces what is inside them. The geometric floor plans, the uniform chisel pattern, the precisely positioned support columns. Scientists from China, Japan, Poland, and Norway have studied the site since its discovery. The 60-degree chisel pattern appears on every interior surface in every one of the 36 caves, walls, ceilings, columns, with a consistency that researchers have described as requiring either a shared template system or a supervisory structure capable of enforcing standards across an enormous coordinated project. The walls taper inward as they rise, a structural technique that distributes ceiling load and prevents collapse. Whoever designed these spaces understood rock mechanics. Ceramic shards found in the caves have been tentatively dated to the Qin dynasty period around 212 BCE, leading some archaeologists to suggest construction during the reign of China's first emperor, Qin Shi Huang, who is known to have ordered massive underground construction projects, including his Terracotta Army burial complex. The total volume of siltstone removed to create the 36 caves is estimated at approximately 1 million cubic meters. That material has never been found anywhere in the surrounding landscape. No spoil heaps, no secondary deposits, no evidence of dispersal. 1 million cubic meters of rock. Gone. The mainstream explanation is that the Longyu Caves were quarries, massive extraction sites for siltstone used in Qin Dynasty construction programs, possibly including the Great Wall or the Imperial Palace complexes. The chisel mark uniformity reflects standardized quarry toolkits distributed across a large workforce. The internal finishing is a byproduct of systematic extraction methods. The historical silence may reflect deliberate suppression. Qin Shi Huang was known for destroying records of his methods and his workers. This is the working hypothesis of the Zhejiang Cultural Relics Bureau, and it is the most parsimonious available explanation. But quarries are defined by what they leave behind. A quarry leaves rubble. 1 million cubic meters of siltstone is approximately 800,000 metric tons of material that must go somewhere. It cannot be dissolved. It cannot be compressed. It cannot simply vanish from a landscape that has been continuously inhabited and farmed for 2,000 years. It has never been found. And quarries do not have interior finishing. They do not have 60-degree parallel chisel marks on ceilings. They do not have support pillars positioned with load distribution precision. You leave structural pillars only if you intend to maintain the space, not extract from it. Every characteristic of a quarry is absent. Every characteristic of a purpose-built interior space is present. Some researchers have proposed that the caves were built as underground storage, shelter, or military facilities whose existence was then deliberately erased from the historical record. The entrances flooded intentionally to conceal them. Others have suggested the ceramic dating reflects the most recent occupants, not the builders, and that the construction predates the Qin dynasty by centuries or millennia. If the second possibility is correct, the Longyu Caves are the largest unattributed construction project in human history, built by a civilization that chose with extraordinary thoroughness to be forgotten. China maintains one of the most comprehensive historical records of any ancient culture. The Shiji, the records of the grand historian completed in 94 BCE, documents the reign of Qin Shi Huang in extraordinary detail. It does not mention 36 underground cathedrals in Zhejiang province. Whatever the Longyu Caves are, whoever built them, they were important enough to construct and invisible enough to erase. The only record they left is the work itself. 36 rooms, each one the size of an aircraft hangar, each surface covered in the same 60-degree marks. The missing million cubic meters of stone somewhere we haven't looked, and a silence in the historical record so complete it feels less like an absence and more like a choice. Top 10. The pattern of lost knowledge. 10 civilizations, 6 continents, a span of human history stretching from 7,500 BCE to the 1st century CE, and the same question asked in 10 different materials, in 10 different landscapes, by 10 cultures that had no known contact with each other. How? The mainstream answer has the advantage of being coherent. Given time, motivation, and sufficient organized labor, humans are capable of extraordinary things. The Antikythera mechanism emerges from a rich Hellenistic engineering tradition. The Maya Venus tables reflect centuries of disciplined, naked-eye observation. Çatalhöyük was built by people whose social complexity we previously underestimated. The Great Pyramid's mathematics arise from practical construction ratios. The Indus Valley's sewers reflect rational problem-solving under demographic pressure. Each of these explanations is serious. Each contains genuine truth. None of them is simply wrong, but they share a common structure. They explain each impossibility in isolation as a local achievement of local genius arising without precedent and then disappearing without transmission. The Antikythera mechanism appears and then leaves a 1,400-year silence. The Indus script encodes the language of 40,000 people and resists every computational tool we have. The Longyu Caves displace 1 million cubic meters of rock that cannot be located. Çatalhöyük maintains social equality across 8,000 people for 18 centuries and is then peacefully abandoned. Each story ends the same way. The knowledge peaks, and then it's gone. What if that pattern is the point? What if the history of human capability is not a straight upward line from primitive to complex, from ignorant to knowing, but a series of peaks and valleys where knowledge is gained, encoded in stone or bronze or chisel marks or bark paper, and then lost, waiting for someone with the patience to find it and the honesty to admit what they're looking at. The 10 civilizations in this video are separated by oceans and millennia. They are not connected by trade routes or cultural diffusion in any way our current maps can trace, and yet they all built things that our best engineers describe with the same word: impossible. That word is not a dead end. It is a door. Most people walk through museums, glance at the photographs, read the placard, and move on. They accept the comfortable answer because the comfortable answer costs nothing. But you stayed through 10 of these. You followed the stones from a Turkish hillside to a flooded pond in Zhejiang. That is not casual viewing. That means your brain is wired to stay with the question after the easy answer runs out. This channel is built for exactly that kind of mind. Not for people who want conclusions, but for people who understand that the most important questions are the ones that make experts sweat. That is who you are. Here's what every one of these civilizations understood that we are still catching up to. The work outlasts the explanation. The gears of the Antikythera mechanism are still in a glass case in Athens. The chisel marks in the Longyu caves are still 60 degrees. The builders are gone, the records are gone, and the names are gone, but the precision remains patient and exact, waiting for us to stop explaining it away and start asking what it means. History is not finished. It is a question that keeps getting asked. If these stories change the way you look at the ancient world and the mysteries hidden beneath our feet, please subscribe to our channel and like this video. We are dedicated to excavating the history that time tried to bury. Let's uncover the truth together. The next great discovery is just around the corner. Stay curious and keep asking the questions that matter.